You were 5 years old when your father places a compass in your hand. The needle trembles, then settles, north. You turn your body, the needle turns with you. You hide under a table, it still points the same way. There is something in the world you cannot see, and it is in control. The realization is quiet, but it feels enormous. You do not forget this. You will spend the rest of your life chasing invisible forces. At 10, you sit in a strict German classroom. Rows, silence, memorization. You were told to repeat answers exactly as written. You hesitate. You want to know why the answer is true, not just what it is. Your teachers see resistance. You feel small in a system that does not reward questions. For the first time, you sense the distance between how you think and how the world expects you to think. That distance will either break you or define you. At 16, a question locks into your mind. What would happen if you ran beside a beam of light? If you could somehow keep pace with it, would the wave freeze in front of you? The thought is strange, almost childish, but it refuses to leave. You leave Germany for Switzerland. You enroll in the Polytechnic in Zurich. You pass your exams, but you are not the top student. You skip lectures you find dull. You study what interests you. You are not trying to impress anyone. You are trying to understand something no one has explained. The question about light follows you like a shadow. Years later, it will unravel time itself. At 21, you graduate. You expect a university post. None comes. Professors do not recommend you strongly. Applications go unanswered. Doors stay closed. There is no dramatic failure, just silence. For a moment, you wonder if the world is right about you. If recognition never arrives, the question about light dies here. But it doesn't. At 23, you take a job at the Swiss Patent Office in Bern. Technical expert, third class. It is not the future you imagined. You examine inventions all day. Clocks, electrical systems, devices claiming precision. Your task is simple. Strip each idea down to its essentials. What is actually happening? What is assumed? What is measurable? The work is repetitive, but it sharpens you. You leave the office, you return to your apartment, you think. No laboratory, no applause, no audience. Just you and your questions. You imagine trains moving at constant speed, lightning striking at both ends, observers disagreeing about when events happen. Slowly, quietly, time begins to loosen, and once time loosens, nothing else stays stable. At 26, you publish 5 papers in 1 year. You argue that light sometimes behaves like particles. You show that atoms are real. You propose that time is not absolute. You write a short equation, E equals mc squared. Mass and energy are the same thing in different forms. You place the papers into the world. Then you go back to the patent office the next morning. No celebration, no immediate recognition, just the same desk. But something irreversible has happened. Physics will never return to what it was. In your early 30s, letters begin to arrive. Universities take interest. Invitations follow. You leave the patent office behind. For the first time, the world leans toward you. Now you must defend what you once developed in isolation. Physicists challenge you. Some resist. You refine your arguments carefully. You push further. If motion changes time, what does mass do to space? Answering that question will take nearly a decade and almost break your confidence. By 36, you attempt something larger. Gravity, you decide, is not a force pulling objects together. Mass bends space-time itself. The mathematics is unforgiving. You make mistakes, you correct them. You doubt yourself, you begin again. Nearly a decade passes inside notebooks filled with crossed-out equations. Finally, you publish the theory of general relativity. Few understand it. You wait. The proof will come from the sky. At 40, an eclipse changes everything. Starlight passing near the sun appears slightly shifted, exactly as your equations predicted. The measurements confirm it. Newspapers across the world print your name. You wake up famous. Your hair becomes iconic. Your face becomes symbolic. Strangers recognize you in the street. The attention is sudden and strangely isolating. You're no longer just a thinker. You are an idea people project onto, and the world will soon demand more than equations from you. In your 50s, the world grows unstable. In 1933, the political climate in Germany turns hostile. As a Jewish scientist, you know returning is no longer safe. You leave behind your home. You begin again in the United States. The questions about space-time feel distant compared to the reality of history unfolding. But your most famous equation is about to leave the blackboard. At 60, you sign a letter warning that nuclear weapons might be possible. Your equation has revealed how much energy is locked inside matter. You are not building bombs, but you understand what your work makes possible. When atom bombs are used, theory becomes consequence. The equation is no longer abstract. It weighs on you. You begin advocating for restraint, because once knowledge enters the world, it cannot be recalled. In your 70s, physics moves in directions you do not fully accept. Quantum mechanics dominates the field. It describes nature in probabilities. You remain skeptical. You search for a unified field theory, one set of equations that ties everything together. Years pass. No final answer arrives. You find yourself once again slightly outside the center. Fame fades. The questions remain. At 76, you are still working. Papers cover your desk in Princeton. You adjust equations. You chase consistency. The same impulse that began with a compass still drives you. You are not always celebrated. You are not always understood. You were often uncertain. But you never stopped asking what lies beneath what we see. The needle pointed north. You spent your life trying to understand why. And even at the end, the mystery was still there.